Okay, so in this chapter, the title of the topic is ratios and graphs. I forgot to write down. Ratios and graphs. So you can see you are learning about this. Ratios and graphs of trigonometric function. When did you learn trigonometric functions? Do you still remember? When did you learn this? You encountered this before, right? Form
3.
3, correct. You learn the sine, cosine, and tangent. So this one is a bit advanced from that one. Okay, so in this chapter 6, you are going to learn this trigonometric function in 2 different subtopics. The first subtopic is finding the value of sine, cosine, and tangent for angle theta, whereby the angle theta is in between 0 and 360 degrees. Okay, so you are looking for the value over there. Whereby the second subtopic is you are going to look about the graph of sine, cosine, and tangent later on. And then you will be able to draw the graph. Okay, now we enter into the first subtopic over here. You see it's a very long description. So in the first subtopic over here, you are going to learn the relationship between the function of sine, cosine, and tangent for angles in quadrant 2, 3, and 4. Okay, so it will involve 4 different quadrants with the corresponding reference angle. Later on, you are going to look into the corresponding reference angle. And then second part, you are going to determine the value of sine, cosine, and tangent for the angles in that 3 quadrants. After that, determine the value of that 3 angle also with corresponding to the angle of 30 degree, 45 degree, and 60 degree. And lastly, you are going to determine the angle when the value is given. Okay, the first one over here, you determine the value when the angle is given, but the last one over here, you determine the angle when the value is given. Okay, so today we are not going to look into so much of it. You don't have to be worried. Okay, we are just going to look at the relationship between the function of sine, cosine, and tangent for the angles in that 4 quadrant. Okay, and then I just briefly explain to you for the second part over here, whereby when it involves the graph, what are you going to learn? You are going to learn the characteristic of the graph. After that, you are going to learn what are the effect of changes to the constant of ABC on the graph later on. And lastly, you learn to solve problem. Okay, so I make it fast. I don't have much time to get ready everything for you for this chapter, so I just copy down everything from the textbook over here. So we are just going to depends on the whole page of the textbook. But don't worry, I'll go through in I summarize everything for you later on. So this part, what will you learn is the one that I already explained to you. We have 2 subtopics. After that, why do you study this chapter? I make it bigger. We study this chapter, one of it, to become an engineer, because engineer use the graph of trigonometric function in the construction of concert halls. If you ever went to the concert halls, you can listen to the music, you can hear the concert. The sound of the music is very nice. So they use it to measure the sound strength so that the sound is clearly heard. Okay, so besides engineer, the geologists also use the graph of trigonometric functions to help them understand the formation of periodic pattern of earthquake and waves. Okay, so the mathematicians that involved here, this one is Hipparchus from, how to name this? Do you know how to read this? Nicaea, is it? Okay, never mind. You can research. Probably right. Okay, he was an astronomer and mathematician known as the father of trigonometry for his contribution to trigonometry. So he developed a trigonometric table in his attempt to understand the movement of stars and moons. Okay, so Hipparchus, okay, is the mathematician. So now we continue. So you can see the eagle on the right. I'm sure it's familiar to you. Have you ever went there?
Oh.
Yes.
No. Oh, I ever went there. If you have time after the COVID is over already, maybe you can find some time to go with your family. One day trip will be enough. If you want to stay for one night, also can. Okay, so this is Langkawi. I also don't know this. I just know about it when I read this. So this is the symbol when you reach Langkawi. You can see the big eagle. It stands very strongly on that island. So Langkawi Island is known as the Jewel of Kedah. We look at the description given. It's one of the tidal stations. So you have any idea what is tidal station? The one that to measure?
Tide.
Tide, right? Yeah, tide, correct. Okay, so a tidal station is built to collect tidal data around Langkawi Island. So this data can be used to detect tsunami waves. As tides occurs periodically, such tidal data can be modeled with graph of trigonometric functions. Okay, so this is basically the purpose that you learn this chapter. Okay, now we look into this. The values of sine, cosine, and tangent for angle theta in between 0 and 360 degrees. Okay, you look at the graph given over here. So we call this a unit cycle. You can see on top of this, a unit cycle. Okay, this diagram here. It is a circle that has a radius of 1 unit. You can see this is a circle. This is 1 unit here. This is 1 unit here. This is -1, but the length is 1 unit. This is -1, also the length is 1 unit. Okay, and then it's centered at the origin here. So the x-axis and the y-axis over here, it will divide the circle into 4 parts. Okay, 4 equal parts, whereby the first one over here, we called it quadrant 1, and then quadrant 2. After that, we have quadrant 3, and then quadrant 4. It is in anti-clockwise direction. Okay, so now you're given a point P over here. It is a point that moves along the circumference in pink color here. Okay, and then the angle of theta will form over here on the radius of the unit of circle. So OP from the positive of x-axis over here, okay, is an anti-clockwise direction. So you can see the angle, the arrow is showing this way. Okay, and then you will find that this thing. Hold on. Okay, so P will be in quadrant 1 when the angle theta is in between 0 to 90. So for sure, you know already this looks like a 90 degree. And then it will be in quadrant 2 when it is in between 90 and 180 degree. Okay, a straight line is 180 degree. After that, it will be in quadrant 3 if it is in between 180 degree and 270 degree. This one, After that, quadrant 4, 270 degree to 360 degree. Okay, so now the next thing that we are going to look into is the relationship between the function of sine, cosine, and tangent of angles in quadrant 2, 3, and 4. Why they only mention quadrant 2, 3, 4? They didn't mention quadrant 1 because quadrant 1 is the same as the corresponding reference angle actually. Okay, we will look into it. So this mind mobilization, over here, you can scan the QR code. I scanned it for you already. So let us look into it for a while. Okay, it's here. Okay, there is a purpose of doing this. When you open up the Geogebra over here, you can see there is a name of the corresponding angle given here with a checkbox. So when we tick the checkbox, you see what is the difference when we tick the checkbox. For the first quadrant, there won't be any difference. Okay, let's see what is the difference on the second quadrant. Okay, so if I move over here, you can see the blue color angle over here. It shows 140 degree. So when I tick the corresponding reference angle, it is the remaining part over here. Okay, I untick again. You see, it's the remaining part after the 140 degree, right? So 180 minus 140, we get 40. Okay, now I move it down. So now the total angle start from 0 over here to this line is 220 degree. let's see where is the corresponding angle. This one is a corresponding angle. Okay, now I move again to the last quadrant. Can you guess which one is a corresponding angle now? Can it be here or can it be here? Let's see. This is the one. Do you notice that? Okay, so I go back to the slide first. Just want to let you know briefly, just now when you look at the Geogebra, so the corresponding angle is actually the one that is nearer to the x-axis. This one, this one, this one, this one. Okay, we go back to the Geogebra. You observe again, huh? Where is the Geogebra? This one. Okay, now I move it to the top. So just like I told you, it's the one that near the x-axis, right? So that's the corresponding angle. So it doesn't change. It remains the same, 40 degrees. Okay, now I move it to the second quadrant. So the angle given is 140. I make it a little bit different. 160 degrees. Okay, can you tell me how much is the corresponding angle?
20.
Very good. That will be the remaining. Can you see that? Okay, now I move it down here. Okay, so this is the angle 220 degrees. Can you tell me how much is the corresponding angle? Can you guess? It will be 220 minus 180 because we want to get this part only. That's the corresponding angle. Therefore, the corresponding angle is 40 degrees. Okay, now I move it to the last quadrant. Okay, so now it's 340 degrees. Just like I told you already, the corresponding angle is the one that is nearer to the x-axis. So can you guess how much is the corresponding angle now? Anybody?
20.
Yes, good. It's 20 degrees. Okay, so at this moment, I let you know earlier, you just need to know that the corresponding angle actually we represent using alpha. It is the one that is close to the x-axis. Okay, now if you look at your book over here, number 5, write the relationship between the corresponding reference angle alpha with the blue angle in each quadrant. Okay, so quadrant 1, the alpha will be the same as the one that is given. For example, we use all the 40 degree. 40 degree, I use 40 degree. So you see the alpha with or without is the same as the corresponding angle. So you can fill in here the alpha is equal to 40 degree. I use the angle of 40 degree. It is the same. And then when I move to quadrant 2 with the corresponding of the same thing here. So you can see this part is 140. This is 40. Okay. So same thing over here for the alpha. In quadrant 2, it will be, how do I get the 40 degree? Actually, it is 180 degree minus 140 degree. So I get 40 degree. Whereas for quadrant 3, how do I get the angle of alpha over here? It is actually equal to the total angle 220 minus the straight line 180. Okay, so I write down it is 220 minus 180. This is the value of the theta. This is the value of the theta. And for the last quadrant, okay, if I move it and make it 40 degree also, so you can see it's a 320 degree. How do I get the reference angle? I'm going to use 360 minus 320. So I write down here 360 minus 320. Again, this is the theta. Okay, so you don't have to worry. I'll let you know later on. Okay, I'll let you see right now. It's easier. Okay, so From the result of the mobilization for the first one, the corresponding angle, reference angle, the alpha, is always less than 90 degree. Is always less than 90 degree, remember? And then angles in quadrant 2, 3, and 4 have corresponding reference angle alpha. The angle in quadrant 1 itself is the corresponding reference angle, the alpha itself. So like the first quadrant that we have just now, if you want to find the corresponding reference angle, it depends on the angle of the theta over here. If it is 20, then alpha is 20. And then for quadrant 2, if you want to get the angle corresponding reference angle over here, you will have to use 180 to minus the theta. For quadrant 3, you will have to use the theta to minus 180, sorry. And for the last one, we will have to use 360 minus the theta. Okay, so this is a formula to find the angle of the corresponding reference angle. Okay, now we have to continue with another one over here because sine, cosine, and tangent, there will be a positive and negative value. That one is just for you to find the angle only. Okay, so now if you look at number 6 over here, drag the red point and choose, drag the red point and choose any blue angle in quadrant 2, 3, 4 to complete the table below. Use a scientific calculator to do the calculation. For example, in quadrant 2. Okay, so I move it to quadrant 2, for example. The theta is equal to, okay, I can change the value over here. 15, 10, okay. Okay, for example, the theta is equal to 150 degree. So remember this, the theta right now is 150, so I'm going to fill in this part over here. In quadrant 2, we are using quadrant 2 right now. We just do one quadrant. I show you one quadrant will do. After that, the blue angle is 150 degrees, just all right. Can you tell me how much is the corresponding angle of the alpha?
30.
How much? 30, very good. Okay, so it is 30. Okay, now we are going to find each of the angle of there by substituting the value of the theta. Do you have your calculator with you? Take out your calculator. Everyone? Okay, so I'm going to find the first one, sine theta. So you just press sine 150 degree, 150. We will get 1/2. And then sine alpha. So there I want you to substitute with the value of 30 right now. So sine alpha will be sine 30. You will get 1/2. Whereas for cos theta, okay, how much is cos theta? I'm going to ask those who attend the lesson today. How much is cos theta? Diana? You got to press it, huh? How much is cos theta? Is everybody there?
Yeah.
Yes,
Yeah.
madam.
Yes.
Okay, Diana got negative 0.x6. Can you give me the answer in the form of fraction, Diana? Change the ST.
Negative 3/2 kah, madam?
It is just 3/2. Thank you, Diana. Okay, so I write down. Next person, can you find the cos alpha for me? Sanai, you are there. Do you have a calculator with you, Sanai?
Yes, madam.
Okay, can you get the cos alpha for me?
Wait, madam.
Okay. The rest, I'm going to assign each of you over here. Fernandez, you get me the 10 theta. Sophia, you get me 10 alpha. The last two. Fernandez, Sophia. Okay, get ready, So Sanai, how much is this? Cos alpha?
So 3/2.
Any negative sign?
No.
No negative sign? Okay, let me try one more time. Cos alpha, so it is cos 30 degree. Okay, no negative sign, thank you. So the first one, cos theta got negative, is it? Let me check.
Yes.
Okay, cos 150 got negative. Sorry, cos 150. Okay, thank you. Fernandez, have you got the answer for your tan theta? Fernandez, are you here?
Is it negative square root 3/3, madam?
Negative 3/3, is it?
Yes.
Correct or not, class?
Yes.
Negative 3/3. Okay, I just follow. What about the last one, Sophia?
3/3.
Okay, thank you, Sophia. So 3/3. Okay, so over here, I'm going to continue. So based on 6 there, you look at 7. Based on table in step 6, compare the value of sine, cosine, and tangent for the blue angle theta. Actually, we have to compare all the different quadrants, but I just show you quadrant 2 only. Quadrant 2 will do lah. We cannot waste the time. Later on, they will have the summary at the back. Okay, so if you look at quadrant 2, only this one, sine theta is equal to sine alpha. Yes or no? Yes, right. And then the value is positive. And then, somebody, can you turn off your microphone? For quadrant 2, cos theta and cos alpha, we compare. So you can see cos theta, if cos theta is negative, cos alpha is positive. Meaning, if cos theta is positive, cos alpha will be negative. That is the meaning over there. And then negative tan theta equal to positive tan alpha. So if it is positive tan theta, then it will be negative tan alpha. So I'm going to fill in here. Are you okay? Are you okay, class?
Yes.
Yes.
Yes. So you can see for quadrant 2, sine theta is positive. Cos theta and tan theta will be negative cos alpha, tan alpha. That the alpha, do you still remember what is this alpha? It is the corresponding reference angle. Okay, so let us look at the relationship on, I think it's on the next page. Okay, give me some time. Here, you remember just now, for the result that we have in quadrant 2, can you see this? Just now we get sine theta is positive alpha, cos theta negative cos alpha, tan theta negative tan alpha. So if you found out everything, you will get the quadrant 3, the result like this, the quadrant 4, the result like this. Okay, but you don't have to worry. It's very simple to memorize. So first one, they will tell you if you want to get the alpha over here, it is equal to positive sine 180 minus alpha. Okay, this one, I'm going to show you with the example later on. I'm sure that right now you don't understand what does this mean. Okay, but you just bear in mind for quadrant 2, the sine is positive, cos is negative, tan is negative. How do we get this? You just refer to this part over here. They already simplify everything for you for the 4 quadrant. So in the first quadrant, all the value of the angle will be positive. In the second quadrant, only sine is positive. In the third quadrant, tangent is positive. In the last quadrant, cosine is positive. So it's like A, S, T, C. Up to you how you want to memorize it. Association of Science and Technology Center also can. Up to you. So we continue. Later on, we are going to apply the rest. But this one, as long as you memorize the ASTC, meanings you already can guess. For example, quadrant 3, T, tangent is positive. So you refer to quadrant 3, you see, only tangent is positive. Quadrant 4, cosine is positive. So cosine is positive. The rest is negative. Are you okay, class?
Yes.
Yes. Okay, we move on to the example. Okay, the example, I need space to show you this part here. Okay, without looking at this, without looking at the answer, because you will confuse when you look at the answer, we need to start with the walking. Okay, Can you see the wording? Can, right? I read out for you. Okay, determine the quadrant and the corresponding reference angle for each of the following. They just want you to find out the quadrant only. So, and also the corresponding reference angle, meaning that this is the alpha. Okay, so easy. If you look at A, 138 degree is in which quadrant? You already can imagine 138 meaning that it moved from 0 to somewhere here, 138. Are you okay? Because the first quadrant is already 90 degree, right? So this is X, this is Y, this is your origin. Okay, so we know 138 degree, I write down now, this is 138, is in the first, is in the, or is located on, which quadrant, class? Which quadrant is this? Yes, second quadrant. So it's located in quadrant 2. Okay, now we already find out the quadrant. We just need to find out the corresponding reference angle. So the corresponding, I write down for the first one to let you see the rest. Later on, we just find out the answer straight away. The corresponding reference angle, the alpha. Okay, so how do I get the corresponding reference angle? Do you remember the alpha that we get earlier using the Geogebra? This one? Still remember?
Yes.
I've told you all the reference angle is near the x-axis. Okay, so we move back over here. We know that the corresponding reference angle is right here. How do we get that angle? Easy, because this part over here is a straight line. So I'm just going to use 180 degree to minus what I have, that 138 degree. Then I'll get the alpha. So we get 42 degree. Are you okay?
Yes.
Yes, huh? So I move on to the second question right now. Okay, second question is 239 degree. So before we do anything, the best thing is you draw your graph. Okay, 239 degree. Draw the graph, label X, label Y with the origin. Move your angle, 239, this is 90, 180, okay, 239, somewhere here. Draw your line. Okay, now, can you tell me 239 is in which quadrant?
Quadrant 3.
Yes, so you just need to change this to quadrant 3. This is 239 degree. Now we need to find the corresponding reference angle. So the corresponding reference angle is here. Correct or not? Because it's the one that is nearer to the x-axis, this one. Are you okay? If this is 239, do you know how to get this one? We just have to deduct the 180. Are you okay?
Yes.
Yes.
Right, so you just need to show it is 239 minus 180. Then you get the answer. The answer is 59 degree. Okay, now we move to the last one. 312 degree. Again, we start with a new graph. You always start with a new graph, then you won't make any mistake. So I start with a new graph. Draw your x and y axis. This one is not compulsory. This one is just for you to determine where is the reference angle. If you got used to it already, and then if the question didn't request it, you don't have to draw. Okay, so now I'm going to draw 312 degree. So from here to here is 90 degree. Here to here is 180. Here to here is 270. So 312 is somewhere around there. I draw the line. So this is 312 degree. Okay, so can you guess where is the corresponding reference angle? Can you guess? This one, right?
Yes.
Okay, now first you tell me 312 degree is in which quadrant?
The fourth.
Which quadrant?
quadrant 4.
Yes, very good. It is in quadrant 4. Okay, now we got to calculate the corresponding reference angle. This one, the alpha. So, do you have any idea how to get that angle in blue? This one? You just need to use 360. One whole turn. You minus 312. Then you get the corresponding reference angle. Okay, so 60 minus 12, we get 48 degree, meaning this is 48. Are you okay?
Yes. Okay.
Yes.
Yes, So if I give you another question, for example, I ask you to find 300 degree. Can you guess 300 degree is in which quadrant?
4.
Quadrant 4. So how much is the corresponding reference angle?
60.
Yes, easy. 60, right? Okay, so you don't have problem in finding the corresponding angle right now. So we are going to move on to example 2. Example 2, this is example 3. Okay, example 2 is up here. This one. Okay, you look at the question. Okay, this is the example. State the relationship between each of the following trigonometric functions with its corresponding reference angle. So now we need to state the relationship clearly. So for example, sine 167 degree. Okay, we go back to draw the graph just now. Okay, this is the graph. Sine 167 somewhere here. Okay, this is x, this is y. So if they ask you to find the corresponding angle, this is the corresponding angle. Therefore, you have to use 180 degree to minus 167. So you can see from line to line here, angle 167 degree is located in quadrant 2. Sine theta is sine 180 minus theta. So sine 167 degree just now is equal to sine 180 minus 167. So actually, you don't have to show this, I think. You just need to show that it's located in quadrant 2. Okay, now you remember in the 4 quadrant, for the first quadrant 1, this one, for the first quadrant, can you tell me which angles are positive? Which trigonometric ratios are positive?
All.
Oh, very good. What about the second quadrant here?
Sine.
Sine, very good. The third quadrant?
Tangent.
Tangent, very good. The last one?
Cosine.
Cosine. Okay, so if you look at sine, you have to refer to the second quadrant. So second quadrant, the sine is positive. Therefore, we don't have to do any changes. You just need to use 180 minus 167 to get the corresponding reference angle. This one, the alpha. Because this one is the alpha right there. This one you learned it earlier in example 1. You just need to apply, but then in example 2, you need to add on right now and then determine whether it's a positive or negative. So after we minus, we get 13. So directly sine 167 is equal to sine 13. You can check with your calculator. Okay, let me show you. Sine 167. Sine 167. Can you remember the figure over here, 0.2249? Can you remember this? Now I press sine 13. Are they the same?
Yes.
Yes, they are the same. That is how you find out the value of the trigonometric ratios. Okay, now we look at B. B is cos 258. So first you need to determine which quadrant is it. Cos 258, which quadrant? Quadrant 3, right? This quadrant over here. So now you can see for quadrant 3, only tangent is positive, meaning that the cos will be negative. Okay, so you can see how do they do it. This quadrant is located in, this angle is located in quadrant 3. So cos theta is negative. Cos theta minus 180. Why theta minus 180? Then you have to apply the one that you learned earlier in example 1. You'll have to get 258 degree. You move. I move it smaller. This is 90 degree, 180. So 258 somewhere here. Draw your arrow. Okay, so this is the alpha. Meaning to get the alpha, this alpha, you have to use the angle 258 minus 180. That's why we have theta minus 180 like this. So it's 258 minus 180 with a negative cos because it's not tangent. Are you okay? Okay, not
yes.
yes, If you're pushing through, let me know. So cos 258 is equal to negative cos 78. Then I'll let you see. You check with the calculator. Cos 258. Cos 258. Remember, it's negative 0.2079. Okay, now I'm going to press, besides cos 258, it's negative cos 78, right? So I'm going to press negative cos 78. Are they the same? The value is the same, right?
Yeah.
Okay, so you just remember there is the relationship in between the trigonometric ratios in the quadrant. Okay, now we look at the last one. So later on, I don't have to show you the calculator already, because you already know that they are the same. Okay, they are the same. So last one, tan 349. Tan 349. So this is 90, 180, 270. So here is 349. Which quadrant is it?
Quadrant 4.
Quadrant 4, correct. So we refer to quadrant 4 here. Only cosine is positive. Meaning if they ask you to look for tan, tan will be negative. Okay, so you can see angle 349 here is located in quadrant 4. So tan theta is negative 10. How to get the alpha here? To get the alpha here, you will have to use 360 minus 349. That's why they have this. So 360 minus 349, you get 11. So tan 349 is the same as negative 11 degree. Any question?
Madam.
No questions. Oh, wait.
Yeah.
We don't need to put like the answer just via cos.
You don't have to show this. You don't have to show this. But because they just asked you to state the relationship with its corresponding reference angle. You don't have to show the second line, but better show this, and this. Okay? But in the exam later on, it depends. I think this one is also not important. You just have to show the last two. But in your exercise later on, you show these three, yeah?
Oh, okay.
Okay, so we move on to the next one. The next one, also quite easy, but I have to prove it to you. Okay, this is the second mind mobilization. Okay, you can look at the step. Look at the end first. It is for you to explore the relationship between the value of sine, cosine, and tangent with the value of x coordinate and y coordinate. Okay, so now we have to find out the relationship for that triangle with the value of x coordinate and y coordinate. Okay, just now is the one in the quadrant, right? Now you have to find out the coordinate. So for example, they give you the steps already. First, you draw the x-axis, and then you draw the y-axis with the origin, and then you mark all the value given. Okay, question number 2, and step number 2, you plot the point. Okay, so these are the points. They have point A, point B, C, D, E, F, G, H. After that, you copy and complete the table. So the table is not complete because they have A, B only, but the one that they have is up till H. But never mind, we do A, B, will do. I'll show you that. So for example, point A, you look at point A. What is the x coordinate and also the y coordinate of point A? Can you see? If you can't, you refer to your book. I think page 177 is page 177. What is the x coordinate of A?
1.
Correct. What is the y coordinate of A?
0.
0. Very good. So y coordinate divided by x coordinate meaning it's 0 divided by 1. 0 divided by 1 equal to
0.
0, yes. Now we move to B, the B over here. Okay, so you refer to B over here. What is the x-coordinate for B? Can you read?
0.
Yes, 0.
0.4.
Correct. What about the y-coordinate? The y-coordinate. How much is it?
0.9.
Yes, 0.9. Okay. What about y over x? Y coordinate over x coordinate meaning 0.9 divided by 0.4. Okay, let's check. 0.9 divided by 0.4, we will get 9 over 40 or 0.225. Okay, it is 0.225. Okay, now we continue down here. Okay, it is given that angle theta is the angle formed by the radius of a unit circle from the positive x-axis in an anti-clockwise direction. Okay, so measure the angle theta from the drawn graph and complete the table as follows. So we look at OA. OA is here, O to A, this line. What is the angle theta over there? Easy, right? How much is this angle here? You know that is in anti-clockwise direction, and then we start from here. So what is the angle over here? It is actually 0, class. If I draw it here, how much is it?
90.
0.
90. 90. If this one, 180. If this one, 270. So this one is a 0, okay? So when they ask you to find the rest of the trigonometric ratio, sine theta, sine 0. So I just press for you, you can see sine 0. The answer is 0. Cos 0. Cos 0. The answer is 1. And then the last one, tan 0. Tan 0. You will get 0. Okay, but over here we cannot prove anything yet. So we have to continue with OB. So let us look at OB. OB means this part here. Okay, so when they ask you for the angle, do you have your book with you? Can you measure the angle of OB? I assume it is something like 65 or 60. Okay, never mind. I use 65. I assume it is 65. So now I'm going to assign you again. I'm not going to find out the value of the trigonometric ratios. See who are here. Okay, Erika, you help me to find sine 65. Matthew, you help me to find cos 65. And Alicia, you help me to find tan 65. 3 of you are here, right? Okay, the first one, how much is it? The first one, how much is it? Sine 65. Erika, are you here? You type or what? No. Erika, are you here? Just now I asked Erika, right? Lost connection, nah? Okay lah. Can't see Erika. Okay, never mind. I do it. Sine 65. So we will get 0.9063. I write down 0.9063. What about cos theta? Just now, who did I assign?
Me, madam.
Oh, Matthew. How much?
0.4226.
4226. Thank you, Matthew. And the last
Okay.
one, Alicia, right? How much is tan theta?
2.1445.
Okay, 2.1445. Thank you very much. So now we are going to compare these two. Wait, I move it here. Okay, we are going to compare this and this. I show you using the arrow. Okay. We are going to compare this and this. So if you look at angle and also the coordinate given, if you notice something, the sine theta, the sine theta, this one, A, the sine theta, okay, this one, with the value 0. The sine theta is actually equal to this. Can you see? They are the same. They are almost the same. After that, if you look at cos, the cos over here, the value of 1. Can you see that, class? The one that I'm circling. And this one is almost the same as this one. Right? And the last one, if you look at tan theta, how come this one is not the same? There must be something wrong. Let me check. 0.9 over 0.4.
2.25.
I wrote the wrong thing. Okay, so it's supposed to be 2.25. So did you notice the value are almost the same? And then for the first one, it's actually totally the same, right? Okay, so they conclude over there, sine theta is equal to the y coordinate. So you remember this. And then cos theta is equal to the x coordinate. So you remember this. Lastly, tan theta is equal to the y coordinate over the x coordinate. This one. Are you okay? So next time when they don't give you the value, they give you the coordinate, the x coordinate and y coordinate, then directly you are be able to determine the value of sine, cos, and tangent. Okay, so let us look at the example. So this is just proving to show you why is it so, why the value of sine theta is like that, why the value of cos theta is like that. Okay, so in general, so you can see here, quadrant 1, quadrant 2, quadrant 3, quadrant 4. In general, if you're given the coordinate of x and y over here, so we know quadrant 1, everything is positive, sine, cos, tangent. Therefore, the value of sine theta is positive. Why? Why? Because just now I told you sine is equal to the y coordinate. Cos is equal to the x coordinate. Tan is equal to y over x. You got to memorize this. Okay, so I go back again. Sine is equal to the y coordinate. That's why sine theta is positive y. Cos theta is positive x. Tan theta is positive y over x. The positive over here, you determine by referring to the quadrant. A, S, T, C. So now we look at quadrant 2. Quadrant 2, only sine is positive. So when they want to get the value of sine, is positive y. And then cos x will be negative. Tan x, y over x. Everything is the same. You see, sine is the y coordinate. 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 Cos is the x coordinate. So you can see all the same. The tangent is the y coordinate over the x coordinate. So everything is the same. The sign is just for you to determine from the quadrant. So this one, S positive, the rest negative. Third quadrant, A, S, T, T positive. So you can see the T positive, the rest negative. And the last quadrant, cos, the cosine is positive. So cosine positive, the rest negative. So you get it, class?
Yes.
Yes, huh? Okay, we move on to example 3. Example 3. This is the last part, huh? Each of the following diagrams shows a unit circle and angle theta. So you're given the angle theta over here with the coordinate. Determine the value of sine theta, cos theta, and tan theta. Easy, right? Because you're given, I make it bigger. You're given the value of the x coordinate and also the y coordinate. This is x. Why like that? Okay, this is x, this is the y. So the solution to get the sine theta, remember the sine, if it is first quadrant, everything positive. So sine theta, you're just referring, it is equal to the coordinate y, which is 0.8829. Sine theta equal to 0.8829. Okay, cos theta is equal to the coordinate x. So cos theta is equal to 0.4695. Can you see that? Okay, and the last one, tan theta is equal to y coordinate over the x. So 0.8829, you divide by 0.4695, you get the answer. Okay, Now we move to question B over here. This is the third quadrant. So third quadrant, A, S, T, C. Tangent is positive. Okay, tangent positive. You just bear in mind. Now we want to find sine for that for that quadrant over here. So you're given the x and y coordinate already. So sine is equal to the y coordinate. It is equal to negative 0.5446. Okay. Cos is equal to the x coordinate is equal to negative 0.8387. And then remember, all of this is negative except tangent, right? So you just add on negative sign. But they already give you the negative sign now, so you don't have to worry. Okay, and lastly, the tan is equal to the y coordinate, this one, over the x coordinate. So you get this. So you will get the correct answer whereby only tangent is positive. The rest is negative. Negative. You get me, class?
Yes.
Yes, so over here, you don't have to really go and memorize. You just need to substitute the value to get the positive and negative sign. Okay, so we will stop here. Okay, and as for your exercise, this is the one, 6.1a. You do all the questions given. All the questions given. So you can see the given question include minute. Hopefully, you still remember how to subtract from the minute. 1 minute, how many seconds?
60.
60.
1 hour, how many minutes?
60.
60. So it's the same, 1 hour and 1 degree is equal to 60 minutes.